No fancy intro, just right to the point. How to build a better EZABL with no soldering and no advanced electronics for under $15. The first video I ever did on this channel was how the accuracy between the EZABL and the BLTouch, and I proved in that video that the BLTouch, being significantly cheaper, is just as accurate as a EZABL. A lot of people commented like, one of the benefits of the EZABL is it's much faster probing, unlike the BLTouch, which has this little probe in the bottom. You know how to deploy and stow. You can just kind of and measure your bed. Unfortunately, I started using it, and in about 4 months or so, this thing stopped working, and it actually ruined my bed. So I had to buy like a couple beds. It actually ruined multiple beds because it would randomly, you can see the little scarring here. It would randomly stop. Sometimes it will work, sometimes it won't. And I reached out to support and was like, hey, this is not working. What can I do? And what they said was, oh, sorry, you're out of warranty. So a product that is on the higher end of pretty much all probes, it's significantly more expensive. So today we're going to go through the parts that you need to build a better EZABL for under $15. It's very simple. You need a probe. You can either buy the thin ones or the fat ones like this. This runs about $10 or so. I think you can actually get the bigger ones for about $7. You're going to buy a bunch of JST connectors like this. If you have your own JST connecting kit, this is going to be, again, significantly cheaper, but you can buy like 200 or you can buy a lot of these for like a few dollars. And you're going to finally buy an Optocoupler like this. You can buy pretty much 10 of them for $10. It comes out like $1 or so each, and this is what's going to be doing everything. So we're going to get started, and we're going to go through what you need to do. It's very simple, very generic, and we'll have a better EZABL. So I don't have any fancy rigs or anything to record everything, but we're going to hopefully kind of show this best to our abilities. We're going to take our little JST connector like this. It's going to have a red and a black wire. What we're going to do is the black, if you look at your Optocoupler and you face it kind of like this, unfortunately I can't get the exact, let's see if I can get the focus here. Nah, it's not going to focus. Alright, so if you're holding it like this, you're going to see ground, out, and VCC on this top. So it's going to say VCC, ground, out. What you're going to do is set the black wire to ground. So all the way, if you're holding it like this, black wire goes on the bottom one. So I'm just going to tighten this. This particular JST, I think I need to strip a little bit, but it's all right. And we're going to take our screwdriver, our flathead, tighten it just a little. Don't tighten it too much because we'll have to reuse this at a later time. And then the red one is going to go into the out. So we're going to like this. So here it is. There you go. All right, we're going to go into out. And we're going to just put that in real quick. Tighten this. All right, so we're pretty secured. All right, so that's pretty much part one. Most of the hard work is done. Some of the hard work, I guess. With these sensors, you can buy one or the other. You can buy PMP NOs or PMP NC. So in this particular one, you can see it's listed. Let me see where it says. This is a PMP NO. I know. This one is a PMP NC. You wanna, I'm pretty sure you can also get the NPN, but for this particular guy, get the PMP. So if you're following this along, search for PMP NO. All right. So in that you have a brown, a blue, and a black. Pretty simple. Unfortunately, again, this is where if you had a wire cutter, you can cut this. This lines aren't big enough. Again, I don't want to add more than what's needed, so we're just going to use our clippers here that you can get with your Ender 3 or pretty much any 3D printer should come with it. And what we're going to do is we're going to kind of slice this along a little bit so we can start separating these. So at the end, it's going to look a little bit like, let me see if I pull this out here. There it is. At the end, it's going to be like split like this so that we can pull these out a little bit. So let's go ahead and do that. In order to do that, let me see if I can get the angle right. What we're going to do is we're going to essentially line up the top of one of the kind of scissors on top of the line so that we're not slicing this. Again, if you have a box cutter, I'm not box cutter, if you have a wire cutter, this is significantly easier, but I want to do this without anything so that to kind of prove that, you know, even without any sort of fancy specific things, you can build a better EZABL. So we're going to go ahead and split this. Just going to nip it a little bit. Obviously, this is going to take a long time because you had to nip a little piece at a time, but it's all right. Patience is key. You want to kind of, again, like I said, you want to guide, you know, if you see this here, you want to use the bottom edge of your kind of cutters to sit on top of one of the wire so that you're not cutting the wire itself. So we're just gonna go right through, get some. So we already had some cuts right here, which is perfect. You can see. We're just gonna keep cutting a little bit until we get a little bit more, and we can peel this back. Voila! So now we have much bigger space for these wires to split out. So this is the part you're going to diverge just a little bit. If you're kind of have your own wire, you just need one extra wire. If you're following this guide verbatim and you have an extra JST connectors, what you're going to do is you're going to snip just the red one so that you have essentially an extra wire, right? So pretty simple. Just take one of your extra JSTs, cut it so you have one wire. The end. Cool. Just to kind of recap, you have your optocoupler. Make sure that LED sign is facing top side. With that, you have your JST attached. The black end of your JST wire is going to go to the bottom one that says ground. The red one, positive, is going to go to out, this particular one. And then on this side, you have input positive and input negative. All right. So the way we're going to do this is let's take our sensor here. So these sensors, they by default come with really long strands. You can hopefully see here. Yeah, you can see this strand. If you have your own wire cutters, or you can just take these and cut them down. I'm not going to do that. I'm just going to do it a little bit differently. I'm just going to bend this in so I can curl them in a little bit. Like so. Hopefully you can see that. Yeah, so I'll just curl them in just a little. I think it's not going to focus. And what we're going to do is we're going to take the brown wire here, the brown one, and it's going to go to input positive. So again, if you're holding your optocoupler like this, with the LED on the top side, input positive, it should be listed. So we're going to put this input positive right here, and let's take our thing, tighten that. All right, we're just gonna kind of hand tighten it a little bit, because we're going to attach our extra wire that we have here into that one as well. So just give us a little bit off, and we're going to attach this wire in there. Tighten that. Cool. So both wires are now attached to the input positive. Next, we are going to take, again, from the sensor, the black wire. We're going to curl it in. You can see this curls that I did. You're going to curl it in and attach to the negative side of input, and tighten that. Boom. So now, just to recap, what we have is, let me put this out here. What we have is the brown wire attached to the input plus, in addition to our extra wire that we'll have kind of dangling around, attached to input plus. the black wire from the sensor attached to input negative. From the JST side, we have the black JST to the bottom to ground, the red JST to out listed in there. And then what we're going to do is we're going to take this blue wire and we're going to attach this to our ground as well. So we're going to undo the ground just a little so it doesn't fall out, just so we have kind of some room in there. And then we're just going to kind of shimmy this in and hopefully it will stick. So let me just undo just a little bit more. Alright, that seems to be it. And tighten. Alright, yep, this is now tightened. Cool, so to give a recap here, we have the out from, oh, there we go, not in focus, the out from JST to red, the black from JST to the ground, in addition to the blue from your sensor to ground. And then on the input side, we have the red dangling wire into input positive, the brown wire from the sensor to input positive, and the black wire from the sensor to input negative. We are pretty much done. Next, what we're going to do is I'm going to take this, assume this is your board. I'm going to take this JST and connect to our Z end stop. So in the traditional Creality board, it is the fourth one. I think if you have an SKR, you probably have more, but whatever is labeled Z end stop, I'm going to plug that there. And then this extra wire that we have, this is going to go to any terminal here that is always on. So I know, for example, well, I think it has to be 12 volt as well. I'm not 100% sure about that, but at least for the Creality board, it's already 12 volts. I plug this in to the hot end fan. So essentially, whatever the fan for your hot end, not the parts cooling, the hot end fan, I attach to the positive side. So let me just turn this. Boom. So if you have a Creality board or an SKR board, I mean, I think pretty much all the boards are pretty much the same. This is how it's going to be right here. So JST to the Z end stop, the extra dangling wire that we have attached to the input positive goes into any terminal positive that is going to be always on. So I use the hot end one because as soon as that's on, it's always on. All right, cool. After you do this, what I would recommend is plug all your motors in, etc. Move your Z carriage all the way up, and then just do a G28 and just manually check to see if your probe is working. Just to see if everything's working. One or two things should happen when your probe is set up. So if your bed goes up, essentially, I believe what this setting is by default is false. So if you go to Marlin configuration.h, Z min probe end stop inverting, just do the opposite of whatever it is currently. I believe by default it's false. So set to true, reflash, and then and test it out and see if it works for you. If not, put it at false. So we're going to do a quick M48 test here to see the accuracy of our probe. So what this does is it probes it 10 times, as you can see in the video on the bottom, and gets a standard deviation to tell us the accuracy. And the closer you are to 0, the more accurate your probe is. Let's see what it says. And as you can see in the background, my Prusa is running, so there is going to be some vibrations coming from that. And even with that, our accuracy is 0.000750. So that's 3 zeros and 750. Let's see what EZABL says about good probes. According to TH3D, a good probe should have a consistently give a range of 0.05. Let me see if I can show that off. There we go. 0.05. That's what a good probe is. Ours is significantly under that. A very good probe such as the EZABL, it will give you under 0.02. Ours is significantly under. So for about $15, we have a probe that is just as good, if not better, than the EZABL. So folks, I want to revisit this after a year to see how it's holding up, and overall I am super happy. So you can see I changed up the fan shroud there for a little bit, but this thing has been printing more or less for a whole year non-stop with very minimal interruptions. There's a couple of things I do want to give a caveat to, all of them which is completely my fault. One, you can see that this is slightly at an angle, largely because I printed all of this in PLA. So when it comes to this side of the bed, the numbers are a little off, but again, that's largely because of this little angle right there. But it's nothing of an issue because I can just mesh edit this one and it prints fine. The other one is a decently large one that's also my fault. There's not much strain relief here. As you can see, I have some wire guide, but not much strain relief. So I print about 100 millimeters a second or higher. So sometimes if I'm doing a lot of movements back and forth, this nut, it loosens up a little bit and it makes it so that this drops or drops a little higher. So one of the things that I had to sometimes do, again, it doesn't happen often, it happens very rarely. I'll have to just re-tighten this and I'm back to normal, and it isn't really much of an issue. But sometimes because this nut is loose, my Z offset will be messed up, but it's a quick fix. Just tighten that and I'm back to being fine.